This video will provide an overview of the pentose phosphate pathway. So set the stage, we're talking about a cell. This happens in most cells, so we're not going to specify what organ, just any kind of cell. Inside the cell, there's going to be a cytosol, and the first thing that's going to happen is glucose is going to enter into the cytosol. Once glucose enters the cytosol, it gets converted into glucose 6-phosphate, so it can't leave again. Glucose 6-phosphate is also known as a hexose monophosphate, hex meaning 6, hexose meaning a 6-carbon sugar, monophosphate, 1 phosphate group added. This G6P would normally go into glycolysis, but it's not going to go into glycolysis this time. Instead, it's going to get shunted to make 6-phosphogluconate. In the process, NADP+ is going to gain an electron and get converted into NADPH. Because electrons are gained, NADP+ is known as being reduced, while G6P is being oxidized because it lost electrons. So this is the first oxidation step in the pentose phosphate pathway. And the enzyme that catalyzes this reaction is called G6PD, or glucose 6-phosphate dehydrogenase. The process to make 6-phosphogluconate actually happens in 2 different steps, making 6-phosphogluconolactone in the middle. The first step, as you can see here, is where the NADPH gains its electron, but this lactone is still in a ring form that has to be broken in the next step, where you see water coming in, breaking that ring, and now you've got 6-phosphogluconate. The next step in the pentose phosphate pathway is 6-phosphogluconate getting converted into ribulose 5-phosphate. This is another step in which NADPH is made from NADP+, which means an electron is gained and NADP+ is reduced. And at the same time, 6-phosphogluconate is oxidized. You can see this reaction in more detail here. Now that the ribulose 5-phosphate is made, it can go 2 different directions. The first direction is to make ribose 5-phosphate, which goes on to do nucleotide synthesis, or it can convert into other molecules that get shunted back into glycolysis, including fructose 6-phosphate, or F6P, and glyceraldehyde 3-phosphate, or G3P. You can see how both G3P and F6P are made via these reactions here. And that is the pentose phosphate pathway.